Okay, let's go ahead and work this, this problem on Newton's third law. And what we're told is there is a shopper, and that shopper is pushing some cart. And what we're told in the problem is that the person exerts 100 Newton force on the ground. So that person pushes that way with 100 newtons of force. Okay? And we're also told that a 10 Newton force of friction and air resistance or whatever resists the motion of the cart. So we'll go ahead and draw that in as well. So the cart, and that's a 10 Newton force. Additionally, we know what the mass of this guy is. He's 60 kilograms. The cart is 30 kilograms. Okay, so that's the problem set up here. And what we're asked, given that information, what's the acceleration of the person and the cart? Okay, so when we figure this, if we figure this out, to figure this out, we want to know, we want to pick an appropriate system. Okay, so given that we know the force the person exerts, and we know the force on the cart, we perhaps want to consider the entire person and the cart as our system for this problem. So let's go ahead and circle our system here, and I'm going to use red for this. So here's our system then. It includes the person and the cart, but does not include the floor. Okay, now why is that important? Because, well, the person and the cart are moving separately from the floor, obviously. And using Newton's third law, this is where Newton's third law comes in, the person exerts 100 Newton backward force on the ground. So by Newton's third law, the ground pushes on the person with 100 newtons of force in the other direction. Okay? So the person then is experiencing 100 newtons of force, and we'll write that in here, 100 newtons of force. And the reason that was important is because, well, this force that's exerted on the ground was not acting on our system that we're considering here. Now we have the force that's actually acting on our system. Okay, so the person pushes with 100 Newton force that way. The ground acts on our system there, person plus cart, with 100 newtons of force in the other direction. Okay? So now that we've identified the forces that are acting on our system, we can calculate the acceleration. And the acceleration is the net force divided by the mass of our system. Okay, and so the net force, we have 100 newtons that way, 10 newtons this way. So 100 minus 10 means our net force is 90 newtons. Okay? Now we need the mass of the system here. We need to put the system mass in here. And the mass of the system is 60 kilograms plus 30 kilograms. So 90 kilograms is the mass of our system then. Okay, so we divide 90 by 90 and we get an acceleration of 1 meter per second squared. Okay, so there's the answer to the first part of the problem. Now the second part of the problem asks a slightly trickier question. The second part of the problem asks what is the force with which the shopper is pushing on the cart? Okay? Now that's a little bit different question. And we really can't answer that question with the system we're considering up here. The reason we can't use this system of the person plus the cart is that particular force we're asked about, the force the person exerts on the cart, is now an internal force to this system. Remember, Newton's second law applies to net external forces. So internal forces don't come into play here at all for this system. Because, well, with the person exerting some force on the cart pushes back with an equal and opposite force. Okay, so using Newton's second law for an internal force doesn't do anything because it applies only to external forces. So we need to consider a new system here that makes this force an external force, so we can then use Newton's second law to solve the problem. And so I think the best thing to do then, you can actually do this one of two ways. You can pick the person as your system. That's one way. The other way would be pick the cart as your system. And so I'm just going to go ahead and do this problem picking the cart as the system. So here's our new system, cart. And I'm just not even going to draw the person in here. I'm just going to have the cart as our system, and we'll go ahead and surround our system with red. So here's our system now. The person is now external to the system. Okay, so what we're told is that friction exerts a 10 Newton backward force on the cart, and the person is exerting some force on the cart, obviously, to push the cart that way. So that person then is pushing on the cart that way, and we'll just call that force F. Okay? So now, this person pushing on the cart, that force is external to our system. And the other thing we know about this particular system from part A of the question is that it's accelerating this way at 1 meter per second squared. Okay? So we've removed the person from the problem now. The person is this external agent that's applying a force to this system, the cart here. So we can now apply Newton's second law. Newton's second law says that the net force, remember this is the net external force, is the mass of the system times acceleration. Okay, so the net force on this object then, we have F pushing that way, and we have a 10 Newton force pushing this way. So the net force is F minus 10. So that's our net force. Now the mass. Okay, we got to be careful what mass we use here. It's the mass of the system. The system now is just the cart. Okay? So the mass isn't the person plus the cart, it's just the cart now. That's our new system. So the mass then is 30 kilograms. And the acceleration is 1 meter per second squared. Okay, so 30 times 1 gives you 30. And remember, the units here are newtons. So F minus 10 newtons is 30 newtons. Add 10 to both sides of that equation, and you find that the force with which the person pushes on the cart is 40 newtons. Okay? Again, you could have done this also by just considering the person as your system. Okay? And acting on the person, there's a 100 Newton force going to the right, and then the cart pushes back at the person with some force that way, which has to be equal and opposite to the force the person pushes with on the cart. So that's the other way you can solve the problem.